Hello everyone, I'm Shital Kuyate from the Computer Science Department of KTHM College. Today I'm going to discuss first chapter of software engineering, that is Introduction of Software Engineering and Process Models. In today's presentation, I'm going to cover following topics. First one is software crisis, second one is why software is important, and third one is the nature of software. And at the last, we'll discuss the definition of software. Let us start with software crisis. So the software crisis, it was in late 1960s. At that time, many software projects failed. Many software projects late, over budget, providing unreliable software that is expensive to maintain. Many software projects produced software which did not satisfy the requirements of the customer. Hence, the complexities of the software projects increased as hardware capability increased. Also, larger software system is more difficult and expensive to maintain. Hence, the demand of new software increased faster than the ability to generate new software. All of these attributes of what was called a software crisis. So the term software engineering first introduced at a conference in late 1960s to discuss the software crisis. Then the question arises, why software engineering? Once the need for the software engineering was identified and software engineering recognized as a discipline, in the late 1970s saw a widespread evolution of software engineering principles. In the year 1980s saw the automation of software engineering and growth of CASE, that is the computer aided software engineering. In the year 1990s have seen increased emphasis on the management aspect of projects and the use of standard quality and process models like the ISO 9001 and the Software Engineering Institute's Software Capability Maturity Model, that is the CMM. These models help organizations put their software development and management processes in place. In 1969, the scientist Fritz Bauer defined the software engineering as the establishment and use of sound engineering principles in order to obtain economically software that is reliable and works efficiently on real machines. According to Boehm, software engineering involves the practical application of scientific knowledge to the design and construction of the computer programs, the associated documentation required, developing, operation and maintaining them. Now, let us discuss why software is important. Software plays an important role in managing business operations as per needs. With the help of software, we can manage and maintain business easily and eliminate human errors also. It is helpful in increasing efficiency, effectiveness, and the productivity of the organization's activities. Then, as all of you know, more and more systems are software controlled, like the transportation section, then the military area, then industrial area, entertainment section, then telecommunication section, and also medical section. Then the next point is the software engineering is concerned with theories, methods, and tools for professional software development. Then it is also important because the expenditure on the software represents a significant fraction of GNP in all developed countries. Let's have a look at the very important topic, that is the nature of software engineering. To understand the nature of software engineering, it is helpful to understand the nature of engineering in general. Engineering has its root of two important human activities, that is the science and crafts. Then, the nature of problems in the software engineering arises from the inherent complexity and diversity, the difficulty of establishing and stabilizing requirements, the changeability of softwares, the abstraction and intangibility of the software. The primary goal of software engineering is to improve the quality of software products and to increase the productivity. Then, the software engineering encompasses every concept and standards of the disciplines in relation to design, coding, and developing maintainable products or the software with the available resources and budget constraints. Software engineering is a discipline that adopts engineering approaches such as establishes methodologies, processes, then tools, standards, organization methods, then management methods, quality assurance systems, and the like to develop large scale softwares with high productivity, low cost, controllable quality, and measurable development schedules. So, under this nature of the software engineering, these three concepts are very important. So, first one is the software, software products, and the software characteristics. Now, software engineering layers. Software engineering is a layered technology. That means to develop software, one will have to go from one layer to another. The layers are related and each layer demands the fulfillment of the previous layers. So the first layer is a quality focus. The quality focus is a basic of software engineering. Software engineering must rest on an organizational commitment to quality. Total quality management and similar philosophers foster a continuous process improvement culture, and this culture ultimately leads to the development of increasingly more mature approaches to software engineering. The bedrock that supports software engineering is a quality focus. Then the second layer, that is the process. It's the foundation for software engineering is the process layer. Process defines a framework for a KPIs, that is a set of key process areas that must be established for effective delivery of software engineering technology. This establishes the context in which technical methods are applied, work products such as models, documents, then forms, reports, then the data. All these are produced. Milestones are established. Means that sometimes delivery date of that particular project we should decide that is the milestones. Quality is ensured and change is properly managed. The software engineering processes ensure that all the technology layers work together and enable the timely development of the software system. Then the third layer, that is the methods. Software engineering methods provide the technical house to for building software. Methods will include requirements analysis, means we are going to study the requirements. Then second, design, we are going to make that particular architecture or the structure of the system. Then program construction, that is the coding. Then testing and support. This relies on a set of basic principles that govern each area of the technology and include modeling activities and other descriptive techniques. Then the last layer, that is tools. Software engineering tools. It provides automated or sometimes semi-automated support for the process and methods. When tools are integrated so that information created by one tool can be used by another tool. A system for support of software development called CASE, that is the computer aided software engineering, is established. Let us see the definition of software. Software is the product that software professional builds and then support over the long term. It is a program or a set of programs containing instructions which provides desired functionality. Also, it comprises of data structures that enable the program to manipulate information. According to IEEE, that is the Institute of Electrical and Electronics Engineers, defines software as a collection of computer programs, procedures, rules, and associated documentation and data. Basically, software includes instructions, data structures, and the documents. Some common attributes of good software are functionality, reliability, usability, maintainability, dependability, efficiency, acceptability, portability, integrity, and robustness. For example, MS Word, Excel, that all of you know, then library management software, that is the according to the customer's need or according to the user's need, we are going to develop that particular software. As we have already discussed what is software, the next concept is software products. So let us see what is product. Computer software is the product that software engineers design and build. It encompasses programs that execute within a computer of any size and architecture, documents that encompasses hard copy and virtual forms, and data that combine numbers and text but also includes representation of pictorial, video and audio information. Then the next question in your mind is, who does it? So the answer is software engineers built it, and virtually everyone in the industrialized world uses it either directly or indirectly. Then it's very important to know why it is important, because it affects nearly every aspect of our lives and has become pervasive in our commerce, our culture, and our everyday activities. Then, the next question is, what are the steps required for these software products? You built computer software like you built any successful product by applying a process that leads to a high quality result that meets the need of the people who will use the product. You apply a software engineering approach. Then, what is the work product? So, from the point of view of a software engineer, the work product is the programs, documents, and the data that are computer software. But from the user's point of view, the work product is the resultant information that somehow makes the user's world better. So there are two types of software products. First one is generic product and the second one is customized product. In that, the first is the generic product. It is a standalone systems that are marketed and sold to any customer who wishes to buy them. For example, graphics programs, then the project management tools, CAD/CAM softwares, Then the softwares for specific market such as appointment system for the dentist or any type of doctor. Then graphics programs, etc. Then the second one is customized product. So the software that is commissioned by a specific customer to meet their own needs or their own requirements. According to that the customer's requirement, we are going to develop that software. That type of software is called as customized products. For example, air traffic control system or the air traffic control software, then embedded control software, then traffic monitoring software, etc. Now let us move to the characteristics of a software. It is very essential to examine the characteristics of a software that make it different from other things that human being built. Software is logical rather than a physical system element. To understand a software, let us consider some of its characteristics. So the first characteristic says software is developed or engineered. It means the software is developed and engineered, but it is fundamentally different from classical manufacturing process. In both the cases, that is in the software projects and manufacturing projects, there are similarities and dissimilarities. So first one is the high quality is achieved in both the cases through a good design. Then both the activities are dependent on the people, but the relationships between the people applied and work accomplished is different. Then the second one is software doesn't wear out. We can say the software is deterministic because it doesn't wear out. Software is deterministic but hardware is probabilistic. Also, the hardware has high failure rates. Hardware fails because of failure modes like a design error, some overload of the component, then wear due to the usage or the poor quality of the component, etc. Then the third thing, that is the software continues to be custom built. It means most of the softwares are developed according to the specification of the customers. So they are customized. That means the customer custom built. Assembling software from existing component is mostly avoided. So all these are the characteristics of software. Let us move to the changing nature of software. Nowadays, all of you know any application on a computer runs through software. As the computer technologies have changed tremendously in the last 5 decades. Then, the dramatic improvements in hardware performance, profound changes in computing architectures, vast increases in the memory and the storage capacity, and a wide variety of exotic input and output options have all precipitated more sophisticated and complex computer-based systems. Nowadays, the software needs to be modified or redesigned according to the changes in user requirements, then the latest technologies, business or the organization rules and strategies. In addition, the complexity of the software also increases. Hence, the software is used in several domains including data science and artificial intelligence, defense, hospitals, banks, schools, online teaching learning, and so on. Let us see various software application domains. A domain defines a set of common requirement terminology, functionality for any software program constructed to solve a problem in the area of computer programming environment. There are several main categories of software domains. First one is the system software, application software, then embedded software, then product line or the business software, then artificial intelligence software, networking and web application software, and scientific software. Today, 7 broad categories of computer software present continuing challenges for software engineers. Let us see one by one. So first one is the system software. It is a collection of programs written to service other programs. Some system software, for example, compilers, editors, and file management utilities, processes complex but determinate information structure. Other system applications, example, operating system component, drivers, networking software, telecommunications processors, process largely indeterminate data. In either case, the system software area is categorized by heavy interaction with computer hardware, heavy usage by multiple users, concurrent operation that requires scheduling, then resource sharing and sophisticated process management, complex data structures and multiple external interfaces. Then next is application software. It is a standalone programs that solve a specific business need. Applications in this area process business or technical data in a way that facilitates business operations or management, technical decision making. In addition to conventional data processing applications, application software is used to control business function in real time. For example, point of sale transaction processing or real time manufacturing process control. Now, the third is the embedded software. So, the embedded software, it resides within a product system and it used to implement and control features and functions for the end user and for the system itself. Embedded software can perform limited and esoteric functions. Example, keypad control for a microwave oven or provide significant function and control capability. For example, digital functions in an automobile such as fuel control, then dashboard displays and braking system. Then the fourth type is product line software. The product line software is designed to provide a specific capability for use by many different customers. Product line softwares can focus on a limited and esoteric marketplace. Example, inventory control products or address mass customers markets. Example, word processing, spreadsheets, then computer graphics, multimedia, entertainment, database management, and personal and business financial applications. And also this is used in schools, hospitals, stock markets, etc. Then the next one is artificial intelligence software. It makes use of non-numerical algorithms to solve complex problems that are not amenable to computation or straightforward analysis. Applications within this area include robotics, expert systems, pattern recognition in image and voice, then artificial neural networks, theorem proving, and game playing. Then the next type is networking and web application softwares. So it is called as web apps. This network-centric software category spans a wide array of applications. Networking software provides the required support necessary for computers to interact with each other and with data storage facilities. Then, in their simplest form, web apps can be little more than a set of linked hypertext files that present information using text and limited graphics. However, as a Web 2.0 emerges, web apps are evolving into sophisticated computing environments that not only provide standalone features, computing functions, and content to the end users, but also are integrated with corporate databases and business applications. It includes all network management softwares, server software, security and encryption software, software to develop web-based applications like HTML, PHP, XML, etc. Then the next one is scientific software. So the scientific software, it is also called as the engineering software. It has been categorized by number crunching algorithms. Then applications range from astronomy to volcanology, from automotive stress analysis to space shuttle orbital dynamics, and from molecular biology to automated manufacturing. However, modern applications within the engineering or scientific area are moving away from conventional numerical algorithms. Computer aided design, system simulation, and other interactive applications have begun to take on real time and even system software characteristics. For examples are softwares like MATLAB, AutoCAD, PSpice, then OrCAD, etc. So, the scientific and engineering software satisfies the need of scientific or engineering users to perform enterprise specific tasks. So, these all are the types of softwares. Now, what the software engineering stands for? The term is made up of two words. First one is software. So software is more than just a program code. A program is an executable code which serves some computational purpose. Software is considered to be collection of executable programming code, associated libraries and documentation. Software, when made for a specific requirement, is called a software product. Then the second word, that is the engineering, is all about developing products using well-defined scientific principles and methods. Then the third definition of software engineering is it's a process of analyzing, means studying user requirements and then designing, building and testing software application which will satisfy those requirements. It helps you to obtain economically feasible software which is reliable and works efficiently on the real machines. According to the IEEE, in its standard 610.12 in 1990s, defined software engineering as the application of a systematic discipline which is a computable approach for the development, operation and maintenance of a software. Thank you.